Hello, today we're going to talk about chemical equations and balancing those chemical equations. So first, just a couple of pieces of terminology. So a chemical equation is basically just a summary of what happens in a reaction. It's kind of like the recipe for what's going on. So the things that you start with in your chemical equation, the things on the left side of the equation are called reactants, and the things that you make or the things you produce on the right side of the equation are called products. All right, so those are just some important terms that you need to know. And when we make it so that everything on the one side of the equation ends up on the other side of the equation, thereby obeying the law of conservation of mass, then we get these numbers in the front called coefficients, and we have a balanced chemical equation. All right, so let's look at an example that's not chemistry to help get us started. All right, so let's say we want to make a cheese sandwich. We know that most of you don't probably need a recipe for a cheese sandwich, right? But we know that we need bread and we need cheese and we'll get a sandwich on the end, right? So this is basically like the chemical equation for a cheese sandwich, but it's not balanced, all right, because that doesn't tell us how much of each thing we're going to need in order to make our cheese sandwich. All right, so if we want to balance our cheese sandwich equation, we know that we'll need 2 slices of bread, we'll need 1 slice of cheese in this particular example, and then when we put them together, we'll end up with our cheese sandwich. Okay, so the difference between the top and the bottom is that we've balanced our equation. It specifically says how much of each thing is going to go in, and everything we started with on the left ends up on the right. All right, so now let's look at an example using chemistry. So let's say we want to make water. We need hydrogen and oxygen if we're going to make a water molecule. Okay, hydrogen comes in nature as H2 and oxygen comes as O2. So that's how we would get our reactants. And our product, of course, is going to be H2O, which is the formula for water. All right, so the problem with this equation is our 2 hydrogens both end up over here. That's great. But we have 2 oxygen atoms here, and we only have 1 over here. So one of them just disappeared, all right? That doesn't work. That violates the law of conservation of mass, and so we need to fix that. All right, so the balanced version of this equation would be to have 2 hydrogens for each of the oxygens in our O2 and make 2 water molecules. All right, and we can show that we've balanced it with these big numbers in the front. They're called coefficients, and that number is multiplied by the whole thing. All right, so 2 H2s means we have 2 H2 molecules, which means 2 times 2, 4 atoms of hydrogen. So that's how we're going to count our atoms in our equation when we have coefficients. All right, let's do some examples. All right, I've written out the steps for you here. And you can see they're there for your benefit, but you may or may not need them. It depends. Okay, so first we write down our equation using correct formulas for reactants and products and include the conditions. So that means these little things in parentheses. So in this equation, we've already been given the correct formulas and they're written out. So we have the CH4 is in the form of a gas. That's what the G means. All of these things are gases in this equation. All right, if you have an L, that means liquid, an S means solid, and an AQ means it's aqueous or dissolved in water. All right, so those do not influence your balancing at all, but they're important pieces to have in your equation to tell you what state the things are in. Okay, so now we need to count the atoms of each element in both the reactants and the products. So we're going to count them separately. Okay, on this side, we have just 1 carbon. All right, and then on this side, we also just have 1 carbon. You need to make sure you look at everything either to the left or to the right of the arrow. Okay, over here we have 4 hydrogens, so that's a 4 there. And then we have 2 oxygens, which gives us 2 here. Okay, over here, we already counted the 1 carbon, 2 hydrogens. It's helpful, I think, to put the your little tally of how many of everything you have in the same order for both sides, even though they don't necessarily appear in that order. Okay, for the oxygen, we have oxygen in 2 spots here, so you need to make sure that you count both of them. So we have 2 here and 1 here. That's 3 total oxygens. Okay, so our carbons are balanced, right? We have one of each. Our hydrogens are not, and our oxygens are not. All right, my suggestion to you is that when you are trying to balance an equation that has an element in more than one place on a particular side of the equation, that you save it until last. It's not always possible, but in this case, we're going to leave the oxygen to the end because it's going to be the most complicated one to balance since it's in two places in our products. Okay, so that means carbons are good, so we're going to balance the hydrogens next. So in order to get 4 hydrogens on the products, so that we have the same number, we'll have to put a 2 here in front of the water. All right, now that will change our hydrogens, so we'll now have 4 hydrogens. It also changes the oxygens, right? So now we have 2 oxygens from water, and we have 2 oxygens from carbon dioxide. So 2 plus 2 is 4. All right, notice that we multiply when we're doing a coefficient to the rest of the molecule, but we add if we're adding elements or atoms from different places in our equation. Okay, all right, so now our carbons are balanced, our hydrogens are balanced, our oxygens, we have 4 here and we only have 2 over here, so we'll have to put a 2 here in front to make that 4 oxygens. All right, and now we have 4 oxygens. The last step is to just double check each of your elements and make sure that you've tallied them correctly. All right, here's an example where we're given words. Okay, this is where that naming that I made you learn earlier in the year is going to come in helpful. So lithium metal, lithium is an element. It's on your periodic table. The symbol is Li, and if it's a metal, it would be a solid. Reacts with liquid water, which is H2O, to form hydrogen gas, which I already told you is H2 in nature, and makes aqueous lithium hydroxide. So that's an ionic compound, and you'll need to know that hydroxide is a polyatomic ion in order to find it on your chart to write out the formula. Right, so this is our formula for our equation for the reaction. So lithium is a solid, it's a metal, plus liquid water, right, so we have a little L here, makes hydrogen gas, have a G, and lithium hydroxide, which is LiOH. Remember that when you're doing these also, Li would be +1 because it's in group 1A, and hydroxide is a polyatomic ion. Its charge is always -1, so we just need one of each in order to make a neutral compound. All right, now let's count up everything we've got. So on each side we have 1 lithium, we have 2 hydrogens here, on this side we have 2 here and 1 here, so that is 3 total. All right, we have 1 oxygen here and 1 oxygen here. Okay, so our lithiums are balanced and our oxygens are balanced. So in this case we can't do my little rule to leave the ones that are in more than one place to the end, because that's all we have to balance right now. So we have 2 hydrogens here, we have 2 hydrogens here, and then we have 1 extra one here. Okay, so on this side, our hydrogens are going to have to come in pairs because they all come with water. All right, so over here, in order to be able to balance, we're going to have an even number of hydrogens. So I'm going to start by trying to put a 2 here. All right, and sometimes you'll have to do more than one change to coefficients to get it balanced, and that is okay. All right, so here, if we add a 2 here, now we've got 2 hydrogens, and 2 hydrogens is 4 hydrogens. But again, we've also changed the lithium, and we've changed the oxygen. So now we have 2 of each of those as well. Okay, which means that we now need to go back to this side and balance everything, because nothing is balanced at the moment. All right, so in order to do that, let's finish up our hydrogen. So we made an even number over here so that we can get it balanced over here. So we'll add a 2, I guess we'll do the lithiums first. So if we have 2 lithiums here, we'll do 2 lithiums there. Okay, and then if we added 2 here, that's going to give us 4 hydrogens and 2 oxygens. Right? And so in the end, we now have 2 lithiums on both sides, 4 hydrogens on both sides, and 2 oxygens on both sides. All right, I didn't mention it last time, but one thing to note, if I leave a spot blank, you can write it just like that. You don't need to put anything in front of that, but it means there's 1 there. We don't write the 1, it's implied. So sometimes on Schoology, you'll need to put a 1, but if you're just writing out the balanced equation, there's no need to put anything in front of the hydrogen, for example, here.